Okay, problem 3, section 5.1. This is just an example. It says to list the zeros in the multiplicity for the function below, determine whether it crosses or touches, and then determine the maximum number of turning points on the graph, and determine the end behavior. That is, find the power function that the graph resembles for large values of x. So to list each zero in its multiplicity, you would take this factor x minus 6 and solve it. Set it equal to 0, you get 6. Its multiplicity is that exponent 3. This one, when it is solved, would be negative 8, and its multiplicity, its exponent, was 2. So you see, you've got all of that. 6, exponent 3, multiplicity. Negative 8, change the sign to. Now it says determine whether it crosses or touches at each x-intercept. If the multiplicity of the 0 is even, the graph will what? The graph touches. If the multiplicity is odd, then the graph crosses. So the smaller 0 is negative 8, because you know negative 8 is smaller. It had a multiplicity of 2. Even number, so it touches. The larger 0 is 6. It has a multiplicity of 3, which is odd, and the graph will cross the x-axis at 6. Then the C says determine the maximum number of turning points. The maximum number of turning points, the graph of a polynomial, is always one less. This is important here. One less. We highlight that. One less than the highest power. Well, if you put this all back together, this term would be an x cubed, and this would be an x squared. And x cubed times x squared, you add the exponents, you get x to the 5th. The lead term would be x to the 5th. So the highest power is 5. One less would be 4. The maximum number of turning points possible is 4. Doesn't mean it has to have that many, but that's the maximum it could have. Then the next problem was determine the end behavior. That is, find the power function of the graph f resembles for large values of absolute x. Okay, basically we did most of the work up here. We ended up with the lead term of being x to the 5th, and that's what it looks like, is x to the 5th. All right. Notice what's here. I put in the original function at negative 8, had multiplicity of 2, we said touch, and that touches. At 6, multiplicity of 3, which is odd, we said cross. It crosses right there. So that is problem number 3.